Hello, all mathematics and scientific discovery enthusiasts. Today, let's dive into the fascinating history of Fermat's last theorem, one of the most famous and intriguing mathematical problems in the history of mathematics. Stated by Fermat in 1637, this theorem resisted all attempts at its proof for over 3 centuries. To understand this enigma, let's begin by exploring Pierre de Fermat, a 17th century mathematician living and working in France, who, as a judge, was passionate about mathematics. One evening, while investigating an equation resembling the Pythagorean theorem, x squared plus y squared equals z squared, which has an infinite number of solutions in positive non-zero integers, Pythagorean triplets, let's take the example of the famous triplet 3, 4, 5, where 3 squared plus 4 squared equals 5 squared. Other examples of Pythagorean triplets include 6, 18, 5, 12, 13, 8, 15, 17, and 7, 24, 25. In each case, the sum of the squares of the two shorter sides equal the square of the hypotenuse. Fermat wondered if powers other than squares could have integer solutions. For n equals 3, Fermat asked the question,
Is it possible to split a cube into two cubes, or any power greater than the square into two powers of the same degree?
Fermat embarked on a quest to find integer solutions to the equation x to the n plus y to the n equals z to the n, with n greater than 2. After extensive searches, he found no solutions and concluded that none existed. This equation proved to be a true challenge, as unlike the Pythagorean equation, it seemed to have no integer solutions for power greater than 2. Fermat was so convinced of his discovery that he noted in the margin of his book De Fontes Arithmetica that he had a truly marvelous proof, but it didn't fit in that narrow space. Unfortunately, he passed away without ever revealing this secret proof. This had led to doubts about whether Fermat ever had a correct proof. It was truly a secret proof he never wrote down. After his death, his son Samuel Clement rediscovered this book with the marginal note,
I have a truly marvelous proof of this proposition which this margin is too narrow to contain.
In fact, the book is filled with these annoying little notes from Fermat. I can prove this, but I have to go feed the cat. I can prove this, but I have to wash my hair. So Fermat was quite annoying in that regard. His son published a new version of the book, De Fontes Arithmetica, the book with all Fermat's little notes printed in the text. And people looked at these notes and they said, Fermat says he can prove this. Let's try. And one by one, people rediscovered the missing proofs. And every time Fermat said, I have a proof, he was right. There was a proof, except in this example here. Fermat's last theorem got its name last theorem because it was the last one that anyone was actually able to find a proof for, and of course, because it's the last one that anyone can prove, it holds a special place and is highly desired. The fact that more people fail to solve it adds to its charm and fascination, and this has been going on for decades and for centuries. Now let's turn to the man who finally unveiled the solution of this mathematical enigma, Andrew Wiles. In the 1990s, Wiles presented a revolutionary two-part proof using advanced concepts such as elliptic curves and modular forms. His proof was complex, requiring 7 years of relentless work to overcome each challenge. In 1994 and 1995, he published his work, finally providing a solid solution to Fermat's last theorem. Andrew Wiles' proof didn't stop there. The mathematical concepts he developed had applications far beyond the realm of pure mathematics. Researchers have used elliptic curves and modular forms in areas such as cryptography and number theory. So, dear friends, Fermat's last theorem remains a captivating example of the power and complexity of mathematics. It teaches us the importance of perseverance and creativity in our quest to understand the universe around us. Mathematics continues to astonish us, and thanks to brilliant minds like Fermat and Wiles, we continue to push the boundaries of our knowledge. Don't forget to subscribe, give a thumbs up. Thank you for joining us, and until next time for more exciting mathematical adventures.